Hello friends, today we are going to discuss our unit number 5. Unit number 5 is related with the shading and the animation. So why we are going to learn the concept of shading, or what is the basic behind the shading, which we are going to discuss in this. What are the different applications for this shading, and after that the most interesting topic of a computer graphics is the animation. How to do the animation, and there will be a few assignments for all of you to do an animation. So first we will see what is shading. So why we are in the need of concept of shading. As we have seen polygon filling algorithm, in that polygon filling algorithm each and every pixel is filled with the same intensity, so we are not having any kind of a shade over there. Each a complete surface is having a same intensity. Now if you want to render a particular object on a screen which is having a different shape, such as this sliding shape, so for that purpose you should have a different shade on each and every side of your polygon, otherwise it will be seems to as a plane. So for that purpose we are having the shading algorithm. So here we are having, so first in shading algorithm we are having the Gouraud shading. So here the concept of Gouraud shading is to fill the polygon with a different calculation. So here the intensity interpolation, the intensity of each and every pixel is calculated with the concept of intensity interpolation scheme is used over here. Now what is this intensity interpolation scheme? We will see in detail. Each polygon surface is rendered with the Gouraud shading by performing the following calculation. The first step in the Gouraud shading is to determine the average normal vector at each polygon vertex. For example, if this is my particular edge of my polygon, so I have to calculate a normal vector over here. Then I will take the average normal vector of this, and for that purpose we are using the formula as normal vector is equal to summation of k, where k is initialized by 1 to n is nothing but the number of vertex. Okay, then we are having nk we will see in detail, that is nothing but a normal vector which we are calculating for this particular vertices. Okay, then we are taking the mod of the summation of k is equal to 1 to n nk, and that will be termed as my average normal vector. This is my first step. If this is my particular point on my object, then we have to calculate the average normal vector for each polygon vertex. Apply an illusion model to each vertex to determine the vertex intensity. Illusion means what? We have to see what uh, by which particular factor the light should be there, by which angle the light should be propagate over there. That is nothing but our illumination model. Then we are having the linear interpolated polate the vortex intensity over the surface of polygon. Then we have to linearly interpolate the vortex intensity over the surface of the polygon. Now the Gouraud shading. Now consider this is our polygon, okay, and we are having a one scan line over there. This is my particular point for which I have to calculate the color intensity. For that I will calculate this point 4.5. These are my two vertex 1, vertex 2, and here we are having the vertex 3 as well. So in our step number 1 we have to calculate the intensity, average intensity. So interpolating the intensity along the polygon edges for each scan line. We are having the different scan line. I am taking one example of this scan line. There will be the n number of scan lines. The intensity at a intersection of a scan line with the polygon edge are linearly interpolated from the intensity at the each endpoint. At the each endpoint. Okay. For example, in the figure, the polygon edge with the endpoint vertex are vertex at position 1 and 2 is intersected by the scan line at point 4. A fast method for obtaining the uh, intensity at a point 4 is to interpolate between the intensity of I1, means what I am talking about, the vertex intensity over here, and the vertex intensity at I2. Using only these two vertical displacement for scan line, we will calculate the intensity, average intensity at this particular position of I4 by using the formula Y4. Now what is this Y4? So this particular point 4 is having X and Y, so I have denoted it as X4 and Y4. Similarly over here we are having X2, Y2, X1, Y1, and here we are having X3 and Y3. So y4 minus y2 means what? Y4 minus y2 divided by this length, that is nothing but r y1 minus y2 into the intensity of this position, intensity between these two, plus now here we are using the concept of different concept of this portion, because we have to calculate the normal intensity over here. So we are taking y1 minus y4 upon y1 minus y2 multiply by the intensity of my second vortex. So this is an important formula to calculate the normal intensity at any particular position. So if you are writing in terms of normal formula, then we will write it as IV is equal to y minus y2 minus y1 minus y2 I1 plus IV minus y1 minus y1 minus y4 divided by y1 minus y2 into I2. Now see, here we have taken the next scan line as y minus 1. Y is there, we have seen this formula. Now have taken the next scan line as y minus 1. So I dash is there, x and x plus 1 will be there. So here I am having the formula as I is equal to y minus y2 by y1 minus y2 into I1 plus y1 minus y divided by y1 minus y2 I2. Now I have to calculate for this I2 I dash. So I dash will be what? We have to write our formulas in terms of I. Once we have calculated for this interpolation, try to understand I1 and I2, we have calculated this, then we can use that I along with I2 minus I1, I2 minus I1 divided by Y1 minus Y2, we will get the next I dash as well. And so on, we will increment or decrement our scan line to calculate each and every point of pixel intensity. Now, what is the advantage and the disadvantages of the Gouraud shading? The Gouraud shading having few advantages as discard the intensity continuation associated with the constant shading model. The linear intensity interpolation can cause a bright or a dark intensity strike. Now what is this bright or a dark intensity strike? Now you can view this key complete glass flash is having a effect as a bright effect over there, though we should have a scratch like this, but due to this match band effect, what is this match band effect? It's appear on a surface. It is a match band effect, that is nothing but we are having the normal intensity. We are taking what we have taken the average intensity. The average intensity, if you are going to calculate from here to here, you will get the intensity as a bright intensity over here. And thus, when we are using the Gouraud shading, this line is disappear, and that effect is known as your match band effect. The match band effect can be decreased by dividing the surface into the higher number of polygon faces, or by using the other method such as phone shading that required a more calculation. So this is the concept of Gouraud shading. We will have one recap of this Gouraud shading. What is this Gouraud shading? So in Gouraud shading, we have to calculate, in Gouraud shading, we are having a 3 steps. First step, we have to calculate the average normal vector at each polygon. What is the formula for that? The NV is equal to summation of k is equal to 1 to n nk divided by mod of summation k is equal to 1 to n nk. Then we have to apply the illumination method to each vertex to determine the vertex intensity. And the last step, we the linear interpolate the vertex intensity over the surface of polygon. And in Gouraud shading, this formula is an important. This formula play an important role. I4 is equal to, remember this formula. When we are talking about the vertex I1 intensity, then we have to consider I4 y4 minus y2. If you are talking about the vertex intensity present at your I2, then your formula will have y1 minus y4 divided by y1 minus y2. Now here we have discussed about the next incremental interpolation of intensity. So if you want to calculate the intensity at I dash, then you can use the formula as I plus I2 minus I1 divided by y1 minus y2. So these are the advantages and disadvantages of your Gouraud shading. In my next lecture, we will see the phone shading.